Next up, we have another guest from Geospatial World, Supriya Krishna. She is an associate partner, and her background is in climate policy, urban development, and geospatial strategy. And she's worked with various government organizations, including the United Nations. And today, Supriya is going to talk about the evolving geospatial landscape and how developers can align their work with industry needs to maximize their impact. So let's give Supriya a warm welcome.
Yeah, thanks for your patience. My name is Supriya. I lead the consulting business and strategy with Geospatial World. We focus on market assessments, impact studies, future trends of geospatial tools and tech. I come from an urban development, disaster risk and climate background. So I have been an end user of a lot of tools that are being discussed in this conference. So this is certainly a very exciting topic for me to reflect upon. This is a session about big numbers and impact, so expect the same, and it's a tall order to be speaking after Mark, so thank you very much for your patience. A few months ago, Whereabouts put out this blog that said that geospatial data isn't special anymore, and that's a good thing. So Iceberg and Parquet now support the geo data types, which means that developers can now work with geospatial data using familiar engines like DuckDB, Spark, Sedona, Snowflake, BigQuery, of course, all without custom pipelines. The processed data can now directly feed into 3D visualization tools like the CZM.js using common open formats such as the GeoJSON, 3D tiles, etc. This change brings geospatial into the modern data stack, and that opens a whole new possibilities for the developer community. I'm going to repeat this slide once again just to emphasize the 1.2 trillion market for geospatial solutions until 2030. And of course, this is not monolithic growth. So if you look at the greens, GIS and spatial analytics, the market is expected to double, driven by the requirement to visualize massive high-resolution 3D data sets from satellites, drones, IoT sensors, and so on. Also, a huge market is the GNSS and real-time tracking segment, expected to more than double. So in a sense, really moving from knowing where something is, but also how it's moving, what's nearby, what's changing, and so on. So if you look at the numbers, in 2024 alone, developers made nearly 5 billion contributions to open source and public repositories on GitHub. This includes both licensed open source and public projects recognized by the OSI. More than 1 million open source maintainers, verified students, and teachers on GitHub. So we are beginning to, of course, see the real world impact of this in specific sectors such as, let's say, health and activity, which rely largely on open location data and tracking. And the last year itself has seen 400 million downloads from over 100,000 apps in this specific sector. And that's really just the tip of the iceberg of the scale of the open data ecosystem that we're talking about. The democratization of data and analytics through open platforms has really been a game changer in a sense. So in the past decade, the number of countries with national open data portals has more than doubled. And in the US, data sets on data.gov have more than tripled. So it used to be 90,000 data sets back in 2013, and which has now moved to over 330,000, which basically means for developers, it's easier access to high quality spatial baselines. What once required high resources can now be done by smaller teams, startups, NGOs. And at the recent Fed Geo Day, the role of open source geospatial was really emphasized for its role in resilience and so on. If you look at the most commonly known mapping tool, OpenStreetMap, the world's largest editable vector data, built entirely by a global community of contributors and developers. Since 2008 until 2020, OSM contributors have added over 400 million buildings and 175 million roads. These are numbers, of course, but what's critical to note that most building data comes from Europe, North America, and Japan. In contrast, regions like Nepal, East Africa, the Philippines, and Indonesia have also seen growth, but that's mainly because of the humanitarian mapping efforts in these regions, because the number of disasters that they're seeing. So this highlights both the impact of global collaboration and the need to close these persistent data gaps. The global momentum around open data mapping and open source infrastructure is tightly linked to a country's geospatial readiness. So that's what we measure in this index, which we call GKI readiness, which is the Geospatial Knowledge Infrastructure Readiness Index, which assesses how prepared countries are to leverage their spatial data. So it basically ranks, in this case, 75 countries on their capabilities of using geospatial data sets, maturity, readiness gaps, their policies around open data, and so on. So at the top is the United States, which has a very mature governance, open access to data sets, at least up until now. Then you have Northern European countries, which also follow strong open data laws, also promoting innovation. But if you look at lower and middle income countries like Vietnam, Nepal, which are also making big strides, especially because of the push for urbanization and climate adaptation, which needs you to focus on open access and digital inclusion, but it's a long road really to really make them geospatial ready. Let's take a step back and look at how broad and dynamic the geospatial developer landscape has become. These are some, let's say, major geospatial categories. So we see 3D visualization and mapping, collaborative mapping, drones, aerial mapping, 3D visualization, and so on. And these are some open source tools and platforms under each of these categories. Now, when we examine the roles of the developer contributing to these open source tools, and these are, we're talking about real positions here, so these are positions that are actually advertised. We are no longer talking about a narrow GIS role or that of a backend engineer. The 3D geospatial tech stack now spans 3D mapping, real-time visualization, spatial analytics, and with that extension, the definition of the geospatial developer has shifted dramatically because this ecosystem now includes not just the technical, those with technical skills and AI modelers and 3D pipeline developers and so on. It also includes standard implementers. It's about developers who need fluency in spatial concepts, understanding databases, really able to think analytically about how geography and geospatial concepts work as opposed to just knowing the technique behind it. This is a text-heavy slide, but I'm going to, and this talks about the big trends in the US geospatial market and economies. That's one of the reports that we do every year and we update it. But I'd like to kind of focus your attention to point number 8, which the big trend is the transition from raw data to a geospatial knowledge infrastructure. So it's not really about just storing and analyzing spatial data, but it's really about creating knowledge systems that are driving real world decisions. So we can visualize this structural shift in the form of a pyramid. So we have raw data at the base to actionable knowledge at the top. So geospatial knowledge is really starting to treat open data as a strategic asset, so which is powering everything from climate policy to smart cities, digital twins, and so on. And a huge contributor here is also generative AI, which is accelerating the shift with the no-code, low-code tools, which are now lowering the barrier for new users. So we are really in this third wave of democratization where geospatial is no longer reserved for the specialists, but it's really about opening up access to this knowledge and hopefully one day a shared wisdom for decisions for global development. So before I close up, I'd like to maybe talk about the 4 big opportunities for developers, especially in the geospatial ecosystem. So the first one really is developers being at the front line of inclusion and sustainability today, because we are building tools that are turning complex data into actionable insights for non-technical users. We are creating visual dashboards, mobile-first apps, offline maps designed for real-world conditions. And this isn't something that's nice to have. It's really essential. Yet support for this remains very limited. Only 15% of low-income countries have open interoperable data platforms. That's where developers can really step in as the last mile connector to really link this data and how it can be usable for them. A recent OpenStreetMap study also shows how deep this imbalance really runs. So countries that have a low to medium human development index, which are basically home to more than half the world's population, are only mapped about 28%, which is really, really low if you look at let's say, the Western world. The same communities, unfortunately, also face the highest risks from climate disasters and health. So this isn't just a data gap, it's a global equity issue, and I think developers have a huge role to play in closing it. A great example is GitHub's climate action plan for developers, which is really tapping into the existing 60,000 green software and climate-focused repositories on GitHub. So it's kind of gives you a sense of how developers can become essential players in, let's say, reducing global emissions. Point number 2, the surge of the smart city, and open spatial data is really essential for inclusive, interoperable digital twins, and cities, more than 500 are expected to start using these twins very, very soon. So by avoiding vendor lock-ins and reducing costs and promoting interoperability, open ecosystems make it possible for governments to really kind of embrace this innovation without having to get locked in with proprietary tech. And there's a lot of open standards right now, like the DTDL by Microsoft Azure, which is kind of, which is programming language independent. So it's designed to be very inclusive to open contributions and cross-platform integration. So these are really the building blocks for diverse applications, which enables a lot of other open platforms like the Copernicus and digital twin sandboxes to provide more functional, more foundational data sets that developers could really capitalize upon. The point number 3 is the shift to a lot of commercial investment in open geospatial tools. So AWS is backing MapLibre. A lot of NGOs and commercial users are scaling Open Drone Map. A lot of climate tech ventures and funding platforms like Trifera and Albedo Space are all kind of up and coming because of a lot of private fund backing it. And I think I reiterate what Mark said, that this is really a new wave and which wasn't seen up until maybe a decade ago. But what's also noticeable is that the contributor landscape is also globalizing. So there's a lot more developers now from India, Latin America, and Africa that are actively shaping these core tools and not just using them. So it's really kind of tools that are supporting more localized languages, their ability to work offline in low bandwidth conditions, and starting to reflect more of the regional priorities, which is really essential to build this kind of inclusive geospatial innovation ecosystem. And developers really are at the center of this. And last but not the least, it wouldn't be proper tech talk if we did not end it with AI. And it's basically required by law now. So even with a broad funding slowdown in the US market, AI continues to surge, especially generative AI. So between 2019 until the mid-2024 last year, investment has poured into major, let's say, Gen AI companies, including a lot of those with geospatial applications. So geospatial AI and geospatial reasoning, as we saw also in this morning's keynote, with Google Cloud, is really its own frontier. We are seeing real traction, especially in the fine-tuning of geospatial foundation models, which is kind of essential for areas like land use mapping, climate forecasting, environmental monitoring, and so on. So this is a space where developers are already and can continue to take an active lead in kind of really grounding Gen AI applications into real-world insights. And yeah, so that's where I think it really has a real transformational power, in a sense. The last slide is really about the promise of the open geospatial data movement. It's incredible, the numbers are mind-boggling, the impact is huge, but there is a real and persistent challenge, both for the developer community as well as governments that actually provide this data. Because at the project level, data conflation is extremely inefficient. And we found these in one of our previous panels from the Geo Business Summit, where merging data sets is extremely time-consuming, resource-heavy, and a lot of cities and counties do not have the internal capacities to start kind of looking at data as a whole. So they still continue to conflate data at the project level, which is really, really not the way to do it. Data access is uneven. I think I already emphasized this enough through the OSM examples, where rural areas and the non-Western world remains largely underrepresented. Privacy concerns are extremely high, especially when we talk about health and location data. There's serious ethical responsibilities for developers here as these data sets become more and more detailed and more interoperable. And finally, while open data benefits many, governments carry a heavy cost of creating, maintaining, and hosting these public assets. So I think now it becomes, let's say, a distributed responsibility of who supports the maintenance of these data sets, keeping them updated, and so on. So with the intention of building not just what's technically possible, but what's really sustainable in the long run. So thank you very much for listening. Thanks to, you can reach me on my email, and that's a link to our other industry reports. Thank you.